right, so today we're going to review how to find the average rate of change or the slope for linear and quadratic or exponential equations. So quick review on average rate of change. It is your slope, and the rate of change is just the line that connects the 2 points. What is the slope of the line that connects 2 points? The important things to remember, for linear functions, there is a constant rate of change, meaning it doesn't matter what 2 points you pick, you'll get the same slope every single time. That's constant. But if we're talking about quadratic or exponential functions, they have a variable rate of change because it really does depend on which 2 points are chosen, because the graphs are curved. So the slope of the line between the 2 points will change depending on which 2 points I pick. But lucky for you, they are calculated the same way. They're all calculated using our regular slope formula, y2 minus y1 divided by x2 minus x1. So to kind of warm us up and get us back on track, I get some basic examples for us here, where I'm just giving you 2 points and you're going to find the slope between the 2 points. So we need to know what is y2, y1. This is the first point, so I'm just going to say that's the x value in the first point. That's the y value in the first point. This is the x value in the second point, and that's the y value in the second point. That's just to help me kind of see how am I going to plug this all in. So my equation says y2 minus y1. Well, my y2 value is 3 minus y1, which is 1, divided by x2, which is 4, minus x1, which is 1. Once you've got it set up, you're just going to start simplifying. All right, so we got 3 minus 1, which is 2, 4 minus 1, which is 3. You want to look to see if that fraction will simplify. For slope, we usually just leave it in the fraction form. 2/3 will not simplify any further. So that is my slope. Let's try our example number 2. So we have the x value in the first, the y value in the first, the x value in the second, and the y value in the second. We're going to plug it into our equation. y2 is negative 2 minus y1, which is 4, divided by x2, which is 10, minus x1, which is negative 2. All right, so what's happened here is I have 10 minus a negative number. Whenever you have minus a negative, that's going to turn into a big old plus line. Okay, so now let's go ahead and simplify this. Negative 2 minus 4 will be negative 6. 10 plus 2 will be 12. We want to see if this fraction will simplify. I do know that 6 and 12 are both divisible by 6. So the top will become negative 1 and the bottom will become 2. So my slope for these 2 points will be negative 1/2. This is a good time to pause the video, try these next 2 problems on your own, and then play the video and see how you did. All right, so let's find for number 3, our y2 is negative 5 minus y1, which is 5, divided by x2, which is negative 8, minus x1, which is negative 4. All right, we have that negative situation again. So that turns into positive right there. Negative 5 minus 5 more is not 0, it's negative 10. And we have negative 8 plus 4 will be negative 4. When I look at these, I got to think, can I simplify this down? I happen to know both of those are even, so they'll both be divisible by 2. If I do that, I get negative 5 divided by negative 2. And when you have the same sign top and bottom, they cancel and everything stays positive. So that's going to be a positive 5/2 is the slope of the line between those 2 points. And for our last one, we have 4 minus 0 divided by negative 2 minus 10. Once we've got it set up, we start simplifying. 4 minus 0 is 4. Negative 2 minus 10 more is negative 12. To look to simplify this, 4 goes into itself and into 12, so it goes into itself once, and 12 is negative, so it'll be a -3. And usually we'll just go ahead and write that negative sign out front like that. -1/3 is our slope. All right. So often you're not going to be given just 2 points and asked to calculate the slope. It's going to be in some sort of other context. So today we're focusing on what if you're given a formula. So to find the slope using an equation, you will plug in the x values given to you to find the corresponding y values. Once you have both points, you will use the slope of the formula as you did above. So the first one we're going to do by hand, but I highly recommend you stop and grab your calculator because I'm going to show you how to do this in the calculator. It's going to be a lot easier for you. So our first one, I'm giving you an equation, and then I say for where x is 0 and where x is 3. So really what it's saying is you're going to have 2 points, one where the x value is 0 and one where the x value is 3. What we don't know is the y value. But if you notice, it says y equals the equation. So if you take the x value and plug it in for x, you'll find out what the y value is. So for our first one, we want to plug in 0. So 6 raised to the x, well, the x is 0, plus 3. What is that going to equal? Well, 6 to the 0, you have to remember your exponent rules. Anything raised to a 0 becomes a 1. So 6 to the 0 is 1, plus 3 equals 4. That's what our y value is for this first 0, 4. Let's try for x is 3. We're going to go back and use the same equation. And where the x is, we're going to plug in 3. So 6 raised to the 3, if you use your calculator, you get 216 plus 3, which means our y value is 219. 219. That doesn't even give us the slope. All we've got now is the 2 points. So from here, we'll go and do what we did above. So we'll say y2 minus y1 divided by x2 minus x1, and I get 215 over 3. I will say this does not cancel down. You can go and check and see, does 3 go into both of those? It does not simplify. This is actually your slope. And then the other thing I want you to do is I want you to identify this as linear, quadratic, or exponential. I have an x in the exponent, so that makes this exponential. All right, so I'm going to make this a little bit easier for you. I'm going to have you do this in your calculator. All right, so take your handy dandy calculator. All right, we're going to go into y equals. All right, so 7x squared, so we say 7x, and we can hit the squared button, plus 5x minus 2. Once you know it's exactly the same, now remember, if you don't have your graphing calculator of your own, you can download an app for Apple or Android. Android is WabaEmu. Apple is, I think it's like TI-84 calculator. You can just Google TI-84 emulator and come up with it. Or you can use Desmos on either your phone or on the computer. Any of these will help you with this. Okay, so this looks different. This doesn't say for x equals anything. It looks almost like I'm trying to give you a point here. But these are actually x values. They're not, it's not a point. So what it's saying is for the x value -2, I want to know what the y value is. And for the x value of 1, I want to know what the y value is. I could plug those in like we did on our first example over here. But the other thing I can do is we put this in the calculator. Then I want you to hit the second graph button to go to your table of values. Once you're in your table of values, I got an x value of -2, so the calculator will plug this in for you, and it's much faster. If x is -2, that says my y value is 16. And if my x value is 1, my y value is 10. So now I have my 2 points, and I can just go on with my slope like I was doing before. So I have y2 minus y1 divided by x2 minus x1. Remember, negative negative becomes a positive. So 10 minus 16 is negative 6. 1 plus 2 is 3. 3 goes evenly into negative 6, and I end up with a slope of negative 2. Okay, so between those 2 points, the slope is negative 2. This is, when I look at it, it's got a highest degree or a highest exponent of 2. That makes this a quadratic. I told you before that a quadratic can have a variable rate of change. That means if I chose 2 different x values, I don't come up with a different slope. It just depends on which 2 I pick. All right, so this is a good spot to stop. Try these next 2 on your own and then come back and check to see how you did. All right, so for number 3, this is just written backwards. It's still a y equals. I can change it. I can say y equals 9x plus 3 if it makes me feel better. I'm going to put this into my calculator. So I'm going to clear and say 9x plus 3. Go look at my table of values. And I'm looking specifically for where x is negative 3 and where x is positive 3. So where x is negative 3, I get negative 24. Where x is positive 3, I get 30. Once you have your 2 points, we're going to do our slope formula like we did before. y2 minus y1 divided by x2 minus x1. All right, so let's take a look at this. We have this double negative happen twice here. So that becomes a positive, and that becomes a positive. 30 plus 24 is 54. 3 plus 3 is 6. I happen to know. I could look to see if they broke down. 2 would go into each, but I know 6 goes into 54 evenly. So I get a 9 for my slope. When I look at the equation, y equals 9x plus 3, the highest degree is a 1. There's really a 1 right there. That makes this linear. All right. Now, what's important about linear is this is y equals mx plus b. Here's my slope right there, 9 and 9. Those will always match no matter what 2 points I pick. It's always going to be a slope of 9 because a linear slope is constant. For our last one, an important note when we're putting the fractions in the calculator, 1 divided by 2, usually I'll go ahead and put that in a parentheses, x plus 6. Go look at our table of values. I want to know where x is 0. So where x is 0, I get a y value of 6. And where x is 4, I get a y value of 8. Once I have my 2 points, I'll do y2 minus y1 divided by x2 minus x1. 8 minus 6 is 2. 4 minus 0 is 4. Those both reduce by a 2, and I get 1/2. When I go back and look at the equation, it's x to the first is the highest degree. That makes this linear. And notice my slope matches my slope in the equation, and it always will because linear slopes are constant. They're always the same number. All right, so for your classwork, you're going to do the same exact thing and put your answers in the quiz on Canvas. Let me know if you have any questions.